Welcome everyone to this week's Science News. Today we'll talk about a potential breakthrough in room temperature superconductivity, new clues about the origin of water on Earth, the best ever model of our geological past, a recent report on academic freedom, an image of the moon taken with a meta-lens, hybrid coral reefs, a new institution dedicated to finding the origin of life in the universe, the first cross-country storage for carbon dioxide, and of course, the telephone will ring. A team of American physicists has announced a superconductor breakthrough again. The group, led by Ranga Dias of the University of Rochester in New York, says it has created a material that becomes superconducting at room temperature, but it needs to be put under pressure. To be precise, they need 10 kilobar of pressure, which they call near ambient. Where I live, 10 kilobar is about 10,000 times atmospheric pressure, but maybe it's different if you publish in Nature. High-temperature superconductivity is basically the holy grail of condensed matter physics. A room-temperature superconductor could transport electricity without loss, which would dramatically improve the efficiency of the power grid and electronic devices. It'd make magnetic levitation an everyday thing. It'd be a really big deal, which is why the topic attracts so much attention. And to be fair, while 10 kilobar is still a lot, it's much lower than the pressure that was required in previous experiments. Here's what they did. They took a thin sheet of the rare earth metal lutetium, just about 10 micrometers thick, squished it between two tiny diamonds, bathed it in a gas made of 99% hydrogen, doped it with 1% nitrogen, and left it alone in a pressurized reaction chamber overnight at 65 degrees Celsius. It's only mildly more complicated than lasagna. Then they squeezed the resulting compound lutetium hydride between the diamonds and watched it change color at around 3 kilobar from blue to pink to deep red. This clearly shows that something is going on. The question is, what? Their major claim is that along with this color change, the electric resistance also changes. In this figure, you see how the electric resistance depends on temperature and how the transition temperature depends on the pressure. The higher the pressure, the higher the transition temperature. Other physicists are somewhat skeptical of the result, and for good reasons. The lead author, Dias, has a shaky reputation after it came out that he repurposed parts of someone else's doctoral thesis for his own dissertation. And 3 years ago, a team also led by Dias already published a paper in Nature about a supposed superconductor breakthrough. However, Nature retracted that paper without the author's consent after other scientists questioned the data analysis and said they couldn't reproduce the results. And several people have already raised questions about the data analysis in the new paper. First, there is the way they get rid of noise in their data. The raw data for the resistance is available online, and without subtracting the noise, it looks like this graph on the left. Gone is the neat and sudden dip to zero resistance. However, this might look worse than it is, because the telltale sign of the phase transition is this sharp drop, and this tail could reasonably be due to other parts involved in the measurement. Other people have pointed out that their spectral analysis seems to be wrongly labeled. This peak here isn't lutetium. One would instead expect magnesium to show up here, but there's no mention of magnesium in the preparation of the sample. Then again, if it works, this might not matter all that much. Yet again, others have raised the point that the resistance seems to have hysteresis, which means that the curves for cool down and warm up are not the same. Superconducting phase transitions normally don't have hysteresis. But while that's unusual, it's been seen before in some materials. At the moment, no one's sure what to make out of this, but there are undoubtedly other groups trying to reproduce the results as we speak, and we'll hear more about this in the near future, so stay tuned. An international team of astronomers has discovered new clues about the origin of water on Earth. It's long been a mystery why Earth has so much water, not just on the surface and in the atmosphere, but also in the crust, mantle and core. The issue is that when our planet formed from the same plasma that gave rise to the Sun, it was too hot for water to form in appreciable amounts. So where does it come from? Did the water form later? Did it arrive with comets or meteorites? Or do we not understand the way that planets form? The new paper looked for answers in a young solar system in the Orion constellation, 1,305 light-years away. They used this system basically as a proxy for looking at the past of our own solar system. Here it is marked in red in the constellation below the belt. For their observations, they used the ALMA telescope, a large radio telescope based in northern Chile, and they got lucky. Usually, water in the disk of a young solar system freezes out into ice at some distance from the Sun, and then it can't be examined with radio waves. But in this case, the star has recently gone through an accretion burst incident. This means it swallowed vast amounts of matter and then exploded, kind of like what happens when you read too many Twitter comments. This burst incident heated the disk, turned much of the water into gas, and allowed the astronomers to measure it. They were looking for what's known as the flavor of water. Yes, water comes in different flavors. Besides Coke Zero, it could be that one of the hydrogen or oxygen atoms are isotopes of the most common ones, so they have different numbers of neutrons in the nucleus. For this study, they specifically looked for the fraction of water in which one hydrogen has been replaced with deuterium, known as semi-heavy water. They found the ratio of semi-heavy water to normal water to be roughly 2 parts in 1,000. This is compatible to the ratio found in the interstellar medium. That's the stuff that floats around between solar systems. The researchers suggest that this means protoplanetary systems directly inherit their water from the interstellar medium, and where it's cold enough, it freezes onto planets and more mobile asteroids and comets, which can then redistribute it. This doesn't entirely solve the mystery of where Earth got its water, because the ratio of semi-heavy water to water on Earth is much lower than what they observed in this other solar system. However, if the water in protoplanetary systems comes directly from the interstellar medium, this means that it's probably abundant in many solar systems. So if we ever move to another planet, there's a good chance you can surf there too. A group of Australian and French geoscientists has developed the most detailed model ever of how the landscape of Earth evolved over the past 100 million years. The new computer simulation allows scientists to trace the rise and fall of mountains, the forming of the continents, the flow of rivers and sediments, the transfer of sediments to the ocean, the movement of tectonic plates, the effects of climate and precipitation, and how all these interactions shape the conditions for life on Earth. Remarkably enough, the model is precise down to a spatial resolution of about 10 kilometers everywhere on the globe, including the deep ocean. This little movie shows the last 100 million years evolution of our planet. Bringing past landscapes back to life is not just interesting to look at, it's also important for predicting how Earth will respond to climate change, because we still don't fully understand how carbon is reabsorbed from the atmosphere. Ocean chemistry, atmospheric composition, surface conditions, tectonic plate activity, and biodiversity all interact with the carbon cycle through feedback loops. It's really complicated. I guess someone's got to figure it out, but I'm glad it's not me. Academic freedom has deteriorated significantly over the past decade in 22 countries, whose population makes up more than 4 billion people, half the world's total, according to the latest release of the Academic Freedom Index. The Academic Freedom Index surveys the state of academic freedom in 179 countries. It's coordinated by the Vidam Institute in Gothenburg, Sweden, and a group at the University of Erlangen-Nuremberg, Germany. The best academic freedom score this year goes to Czechia, though much of Europe is in the top group. At the rock bottom is North Korea. In this map, the pinker the color, the worse the situation for academic freedom. For their evaluation, they looked at freedom to research, teach, exchange and disseminate information, cultural expression, institutional autonomy, and campus integrity. You can see that across big parts of the globe, the state of academic freedom is poor. What's particularly worrisome this year is that academic freedom has declined in the 3 most populous nations in the world: China, India, and the United States, as well as Mexico and the UK. In India, academic freedom began to decline in 2009 and then took a steep dive after Modi became Prime Minister in 2014. Since 2016, the report classifies India as an electoral autocracy rather than a democracy. The United States used to have a very high level of academic freedom, but things changed when Donald Trump took office as president in 2016. More worrying, 4 or 5 indicators of academic freedom have continued to fall in the US since his successor, Joe Biden, came to power. According to the report, that's because individual states have taken aim at academic authority. That includes banning certain topics, such as critical race theory and targeting tenure. In some states, lobby groups are trying to have funding withdrawn from gender and environmental studies, and various groups are maintaining public watch lists of researchers that they claim are radical leftists. However, the authors of the report also note that despite all that, scholars in the United States remain able to publicly voice their opinion. In the UK, things have been slowly going downhill for about 10 years or so. As for Mexico, the trigger for diminishing academic freedom has been the country's harsh austerity measures under President López Obrador, who came into office in 2018. In China, things were bad already, but got worse after Xi Jinping became Secretary General of the Chinese Communist Party. Though, as you can see, academic freedom hasn't yet reached absolute zero. That's because you still have freedom of expression. You can say you agree with the Communist Party, or that you support the Communist Party, or that you admire the Communist Party. Plenty of options. The choice is only yours. An American team of electrical engineers, mainly at Pennsylvania State University, has taken the first image of the moon using a telescope fitted with a meta-lens. Conventional telescopes have large lenses and apertures made of bulky, heavy materials such as glass. This, for example, is the lens for the telescope that will be installed in the Vera Rubin Observatory in Chile. So material scientists have been trying to figure out how to make lighter, less expensive lenses by designing materials with nanostructures, the meta-lenses. Meta-lenses are not lenses in the traditional sense. They consist of several layers, each about 100 nanometers thick, carefully configured so that they reflect light in just the right way to focus it. But it's been a challenge to make a meta-lens with an aperture big enough to focus on celestial objects. In this new work, they made a meta-lens by laser etching patterns into silicon and then fused that to a silica substrate. You can see the lens itself here in the middle of the bottom row. And the nanostructures that act as tiny antennas are here in image F. With this method, they were able to create a refractive meta-lens with an 8 centimeter aperture. And that was big enough to get an image of the moon, even if it's a blurry one. Here's what they got. In case you're kind of unimpressed because your 5-year-old took a better pic with his phone, that's quite possible, but the lenses in your phone are one of the reasons for its width, and meta-lenses could be smaller, thinner and cheaper. And then you wouldn't have to worry so much that the 5-year-old drops the phone. Hello. Hi, Elon. Yes, they used to say that money only makes you happy up to a point. But the new paper now found that money makes you happier, unless it doesn't. Well, they say that some people just don't get any happier. Why are you asking? I understand it must be difficult to be rich, but buying Twitter was a really good start to solving that problem. Love you too. Bye! Researchers at the University of Miami are building artificial coral reefs to protect the city from storms and sea level rise. Earlier this month, they sank 27 concrete structures into shallow water, 215 meters off the coast of North Miami Beach. You can see from this overhead drawing that they are 9 meters apart in a line spanning 35 meters. Miami is a hurricane hotspot, and hurricanes can damage coastlines. So the researchers came up with structures that can absorb the energy of storm surges. The next step is to seed them with corals that have been hand-reared at the university. According to their estimates, adding corals to the structures will reduce both wave heights and wave energy by 10 to 15%. The project is important not just to protect people living near the coast, but also an attempt to restore sea life. Since the 1950s, half of living corals across the ocean have died off from ocean warming, ocean acidification, overfishing and disease. And the concrete blocks are ugly enough to deter tourists. An international group of scientists, including 2 Nobel laureates, has established the Origins Federation. It's a multidisciplinary research consortium aimed at understanding how life emerged in the universe and whether it exists anywhere else. The question's been around ever since humans have figured out that there are other stars in the universe, but now that we have found so many exoplanets, it's become even more pressing. I find this an interesting development because up to now the attempt to find alien life hasn't been taken very seriously, and this is changing now. And while the field has traditionally been dominated by astronomers and astrophysicists, the new federation plans to draw on disciplines as diverse as synthetic biology and paleoecology. Why did they call it the Origins Federation? I guess it's either because there is already an Origins Institute, or because they've watched too much Star Trek, or possibly both. The Federation was announced during a panel discussion last week at the annual meeting of the American Association for the Advancement of Science in Washington, D.C. The founding institutions are Harvard, Cambridge University, ETH Zurich, and the University of Chicago. Notable people that will contribute to the project are the Swiss astronomer Didier Queloz, who shared the Nobel Prize in Physics in 2019 for discovering the first exoplanet, and Jack Szostak of Harvard, who shared the Nobel Prize in Medicine in 2009. His lab is currently trying to understand the transition from chemical evolution to biological evolution. The Federation's inaugural conference is scheduled to take place at Harvard University in September. All this would be easier if we could at least agree on what we mean by life. The Danish government has launched a deep-sea graveyard for liquefied carbon dioxide. It's called Project Greensand, and it's part of the current spate of 200 or so carbon capture and storage projects around the world that are supposed to save us. CCS has become all the rage as nations try to meet net zero targets by 2050. At the moment, the world has about 36 or so carbon capture and storage facilities in operation. The Danish project is so far unique because it's the first to store carbon dioxide from another country, in this case from a chemical production plant in Belgium. At the plant, the carbon dioxide is liquefied, then shipped to the site of a depleted Danish oil field underneath the North Sea. There, it's injected by a dedicated well into a sandstone reservoir. The plan is that it stays there forever, or at least until no one can remember we put it there in the first place. They say that by 2030 this carbon cemetery will store up to 8 million tons of carbon dioxide a year. That's about 13% of current Danish emissions and a sizable share. But it's not all peaches and cream. It takes about a fifth of those emissions just to capture, transport and store the liquefied gas. So another little step of progress, but I guess we're still not done dusting off the solar panels this week. I've been doing these YouTube videos for some while now, and I still find it odd, because, just among us, I personally prefer reading over watching videos. If you know what I mean, I have a special offer today from our sponsor Nautilus that I'm sure you'll find interesting. Nautilus is a literary science magazine. They care about writing and they use it to its full potential. In my totally unbiased opinion, Nautilus is presently the best literary science magazine out there. What I particularly like about them is that they cover all areas of science, from astronomy to economics, history, neuroscience, philosophy and physics. They'll keep you well informed on the largest and most important conversations we're having today. I've written several contributions for Nautilus myself. In fact, I'm supposed to be writing one right now. But I'm a small fish. Some of the most well-regarded scientific minds in the world read and write for Nautilus, as well as literary giants like Cormac McCarthy. That's the guy who wrote Blood Meridian. He published the first non-fiction piece of his career in Nautilus. You can join Nautilus as a digital-only member or get a print subscription to receive 6 of their beautifully illustrated editions. In addition to full access to all the stories in Nautilus, members receive benefits like priority access to events, exclusive products and product discounts. For example, they recently partnered with the Australian streetwear company Jungles to draw attention to ocean science. The revenue goes to their Ocean Conservation Fund. Nautilus is really much more than just a magazine. Memberships to Nautilus seldom go on sale, but today we do have a discount to offer. If you use our custom link nautil.us/Sabine, you'll get 15% off your membership subscription. So go and check this out. Thanks for watching. See you next week.